A man who is 5 feet tall is walking at a rate of 3.5 feet per second away from a light that is 20 feet above the ground. When he's 10 feet from the base of the light, answer the following questions. Using that information, we can make this triangle because the light casts a shadow in that shape. And the first question is, what is the length of the shadow? Using that the information from the triangle, we could set a proportion to find y when x equals 10. So the sides of the big triangle, 20 and x plus y, over the triangle within the bigger triangle, 5 and y. Then you plug in 10 for x because that's the distance behind him. So then from there we could cross multiply, and then we could just simplify it down to y equals 4 over 3, or 3.333. The next question, at what rate is the length of the shadow changing? So this question is asking what the rate of change of y is when x equals 10. So for this one, we use the same proportion but cross multiply it first. Then we get 20y equals 5x plus 5y. Then we take 5y from both sides and get 15y equals 5x. And then from there, we find the derivative of that, which is this. And then since we already know what the rate of change of x is, 3.5 feet, because that's the rate of change that he's already walked, we could plug that in. So 5 times 3.5, which is 17.5, and then you would divide by 15 on both sides to get derivative of y by itself. And then you get 7 over 6 feet per second. The next question, at what rate is the tip of the shadow moving? You find what the derivative of the rate of change of x and the rate of change of y is. And we already have those numbers from the given 3.5 and what we solved for the last one, 7 over 6. And then when we add those together, we get 4.667 feet per second, or 14 over 3 feet per second. The next question, at what angular rate must he lift his head to visually track the tip of his shadow? That's asking for to find the rate of change of theta for this corner over here when y equals 4 over 3. We could find tangent of theta, which is opposite over adjacent, and then we plug in the values for the small triangle. So 5 is opposite adjacent is y. Then we find the derivative of that, secant squared theta times derivative theta equals 5 over y squared times derivative y. And we know that secant squared theta is equal to hypotenuse adjacent squared. So first we have to use Pythagorean theorem to find what hypotenuse is. And then we find that c equals 6.009. And then we plug everything in that we already know. And then we get this, which is 0.162 radians per second.